Hello, welcome to the Module 5 of 18 CV 55 Municipal Wastewater Engineering. In the session 2, we're going to discuss about some of the methods which are used in the advanced wastewater treatment, like ion exchange process for wastewater treatment, ultrafiltration of wastewater, then electrocoagulation treatment of wastewater. See, these ion exchange ultrafiltration have been already studied in the treatment of water, and these techniques are also being used for the treatment of wastewater also. As you know, the wastewater to reuse the wastewater or further the usage for the industrial purposes, we have to remove some of the chemicals which are present in the wastewater, which are not generally removed in the normal treatment processes like the primary treatment and the secondary treatment. So we go for these types of advanced treatment. So let us see what exactly is ion exchange process as per wastewater is concerned. Ion exchange process. Ion exchange can be used in wastewater treatment plants to exchange one ion for another for the purpose of demineralization. As I said, demineralization has been done in the water treatment also to remove the solids, the soluble solids which are present in the water, and to make the water soft. And the same technique has been used for the wastewater treatment also. The widest applications of this process is in the domestic water softening, as I said, where sodium ions are removed on cation exchange resin and chlorates are removed on an ion exchange resin. So this is the schematic diagram. The influent, the wastewater is passed through cation resin, then it is passed through anion resin. So the exchange of ions takes place, which results in the removal of soluble solids and removal of some nutrients, removal of some chemicals from the wastewater. This is how the technique is. Ion exchange is a unit process in which ions are removed out of an aqueous solution and is replaced by another ionic species. The basic principle behind ion exchange is that a weakly bound ion can preferably be displaced by a stronger binding ion. It can be operated in a batch or continuous mode and has been used for removing nitrogen. As I said, removing nitrogen, removal of heavy metals, and removal of total dissolved solids in the wastewater. In these applications, definitely this ion exchange process plays an important role, and which give very good high quality effluent, and definitely those effluents can be reused in the factories or can be disposed of without any fear to a nearby lake or river. So removal of nitrogen, heavy metals, and total dissolved solids are done using ion exchange process. The process is just an exchange of ion in the aqueous solution. And another process which is used is called as a membrane process. Membrane technology can be used to treat a variety of waste, including sanitary landfill leachate, containing both organic and inorganic chemical species, water soluble oil waste used in metal fabricating and manufacturing industries, solvent water mixtures, and oil water mixtures generated during washing operations at metal fabricating facilities. So this membrane technology is used to treat these types of waste. Depending upon the material used for membrane and nature of driving force and separation mechanisms, the membrane processes can be classified into sub-processes such as electrodialysis reverse, microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. So these are the some of the sub-processes that will come under the the main process called as membrane process. Let us see what is electrodialysis reversal. Electrodialysis reversal is an electrodialysis reversal water desalination membrane process that has been commercially used since early 1960s. An electric current migrates dissolved salt ions, including fluorides, nitrates, sulfates, through an electrodialysis stack consisting of an alternating layers of cationic and anionic exchange membranes, periodically 3 to 4 times per hour. The direction of ion flow is reversed by reversing the polarity of the applied electric current. This is the schematic diagram of an electrodialysis reverse. Understand? The monovalent electrolysis with flux CD are selective. Understand? A brine rejector is there. Processed wastewater is coming out of this one, where the chlorides, the calcium, sulfates, and sodium are removed to 90%. And the red one is the monovalent anion exchange. This is the cation exchange membrane. Organics do not transit or fold membranes. Another sub-process is called as ultrafiltration. Ultrafiltration physically separates solids from liquid streams based on the principle of size exclusion. Ultrafiltration is a membrane filtration process similar to reverse osmosis, using hydrostatic pressure to force water through a semi-permeable membrane. Ultrafiltration is a pressure-driven barrier to suspended solids, bacteria, viruses, endotoxins, and other pathogens to produce water with very high purity and low cell density. Another important process nowadays, which is more popular, is called as nanofiltration. Nanofiltration is a relatively recent membrane filtration process used most often with low dissolved solids, water such as surface water and fresh groundwater, with the purpose of softening and removal of disinfection byproduct precursors such as natural organic matter and synthetic organic matter. So here, this is a diagram how the nanofiltration works. During nanofiltration, pressure is used to force the contaminated source water through a semi-permeable membrane. So the contaminants that can be removed in this are bacteria, colloids, suspended particles, viruses, proteins, monovalent ions that are present in the effluent of a secondary wastewater treatment, and it passes through a nanofiltration member, and nanofiltration members removes nearly all bacteria and viruses, most organic matter, divalent ions, and up to 90% of monovalent ions. So, if you want to have a very high quality effluent from a this one from a sewage treatment plant, you cannot expect from a secondary wastewater treatment. Therefore, a tertiary treatment has to be done, and this nanofiltration is one of the sub process of ultrafiltration, where it removes the contaminants like bacteria, colloids, the suspended particles, viruses, proteins, etc. Another sub-process is called as reverse osmosis. It is a water wastewater purification process that uses a partially permeable membrane to separate ions, unwanted molecules, and larger particles. In reverse osmosis, an applied pressure is used to overcome osmotic pressure, a colligative property that is driven by chemical potential differences of the solvent, a thermodynamic parameter. Reverse osmosis can remove many types of dissolved and suspended chemical species as well as biological ones also from the water, and used in both industrial processes and the production of potable water. The result is that the solute is retained on the pressurized side of the membrane and the pure solvent is allowed to pass the other side. This is the diagram of an osmosis and a reverse osmosis. You can see here. Seawater is taken, and if it is externally, if you apply the pressure, then what you get is a water with low solids. That means it's as good as a fresh water. Another process which is nowadays being used is called as electrocoagulation, which is used for the treatment of wastewater. Electrocoagulation meaning to apply an electric charge to water or wastewater, and coagulation meaning the process of changing the particle surface charge, allowing suspended matter to form an agglomeration. Electrocoagulation is an advanced and economical water and wastewater treatment technology. It effectively removes suspended solids to submicrometer level and breaks emulsions such as oil and grease or latex and oxidizes and eradicates heavy metals from water without the use of filters or the addition of separation chemicals. What I shown in the previous slides, where we use filters for ultrafiltration, nanofiltration, whereas here in this electrocoagulation, we are going to use the electric current and coagulation technique, and we are not going to use the filters. An electrocoagulation system essentially consists of pairs of conductive metal plates in parallel which act as monopolar electrodes. It furthermore requires a direct current power source, a resistance box to regulate the current density, and a multimeter to read the current values. The conductive metal plates are commonly known as sacrificial electrodes. The sacrificial anode lowers the dissolution potential of the anode and minimizes the passivation of the cathode. The sacrificial anodes and cathodes can be of the same or of different materials. So, an electrocoagulation unit, typical electrocoagulation unit consists of a feeding tank, a reaction chamber with the electrodes, a development tank where the reactions are initialized within the reaction chamber, and a sludge separation unit which is specific to various types of effluent treated. Here is a diagram. One, one is nothing but a feeding tank. Then the second one is the reaction chamber where the current is given, and development where the reactions are initialized within the reaction chamber. Three, and finally, fourth one is the sludge separation where the treated effluent is separated with the sludge. So these are all the most advanced tertiary treatment methods used to remove total dissolved solids, to remove nutrients, to remove chemicals and heavy metals from the wastewater. Thank you.